Okay, so in this video, we are going to look at two geometry problems. The first problem says prove that uh, the angle PTS from this image here is the same as 2 times the angle of OPS. So what do we have here? Given is a circle, and there is a point outside the circle that is um, given, and the tangent from two tangents constructed from that point. Okay, so given is the circle. So given is circle with the center O and radius OP and point T outside circle. And what we want to prove is that the angle PTS, so that's this angle here, is 2 times OPS, which is the angle here. So we are looking at the relation between these two angles. I'll just use a different color. Now I have started here already some sketches which are useful in this in the solution of this problem. There are some things that we are supposed to know with regard to tangents, tangent lines and circles. So as you maybe know from any courses of geometry, the basic fact is that TP is congruent to TS. And also from basic geometry, we have that OP and OS are also congruent because they are radii of the same circle. So OP equals OS. This means that tangent segments from the same point to the same circle are congruent, and this is radii of the circle. Nice. And not only that, here we can see, for example, immediately that the triangle TPS, sorry, let's start with that one. So if you look at this triangle here, so this triangle is isosceles. Why? Because of this fact here. So this fact implies that this triangle here is isosceles. And also this fact here implies that the triangle OPS, which I mentioned now, is also isosceles. So this means that this triangle is isosceles. This means that the angles on the base have the same size, so they are congruent. And also we have the fact that these two angles here are congruent as well, because of the same fact. So in a isosceles triangle, in any every isosceles triangle, the angles on the base are congruent, and we can see that if we connect OP and OT now, sorry, O and T. So that's the here connection. We can notice further that using side, 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 the triangles are congruent, and I will just see if I can develop that here further. Yeah. And so let me just create some space here, so that we can see, and then I will come back to this and we will prove in more detail what we need. So if we now connect O and T using the fact that everything what we said, you can go back and see. So we have said that these two are congruent, and also these two are congruent. So we have that OP is congruent to OS. They are ready. Then ST is congruent to PT as tangent segments. Okay, and we have also the fact that OT is congruent to OT, same segment. Now using side, 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 we conclude that OPT is congruent to OST. From here, we easily see that we can conclude that here also the OT is actually normal. So OT is perpendicular to PS. If you notice, just as a matter of analysis, that's not mandatory here for the development of the task. The figure that we obtained is quadrilateral. You can have something like this, which is called a kite. And in this kite, the diagonals are perpendicular. So this is O, this is T, this is P, this is S, and we concluded some interesting facts. Now, what I had previously, I will just concentrate now on the one of the triangles. I will call this a line of intersection M, and here is M, here is then O, here is T, yes, and this is P. Now, what we want to prove, looking at this image here, basically we want to prove that this angle here is the same as this, but 1/2. Okay, so that means that since, as we have seen, that OT is perpendicular, it is also bisecting this angle here. So if you look at OT, it bisects this angle here. So one strategy here, and sadly not the only one, is to show, so claim, is that OMP, triangle OMP, is similar, so not congruent, similar to OPT. Okay, so this is our claim. And if we prove that, then we are done. Because in that case, the angle OPM, which is the same as the angle, which is the same as this is here S. So if we prove this similarity, we'll have the proof done, because in that case this angle is, so OPT is the same as the angle PTO or PTM, same angle, and which is 1/2 of PTS, and that is what we need to prove. So this is the same as 1/2 PTS equals angle OPS. Now angle OPS, you may also notice that that is the same as angle OPS is the same as angle OPM. So this is one way, this is not the only way, and this is not the maybe most obvious way how to prove it, but again we can prove. So we have here again the same image. So why would this be true? Why would OMP be similar to OPT? Well, obviously there is at least one common angle, which is, so angle HM is congruent. It's congruent to the angle at P. Why? This is due to the fact that M is right and P angle, okay, angle is also right as a tangent angle. So we know when we have tangent, this angle here is a right angle, and M is the midpoint of the base of an isosceles triangle. Therefore OM is perpendicular. So let's write that down here. So OM is angle bisector in isosceles triangle meeting the base. Therefore OM is perpendicular to the base, which if you look at here, that means that OM is perpendicular to PM, which is PM. So OM is perpendicular to PM, and on the other side, here again you can see that, so here is a right angle, here is right, here is M. And OP is perpendicular to TP as a tangent line is perpendicular to the radius. So this is radius is perpendicular to tangent line. This is theorem. So indeed these two, this is correct. They are congruent as two right